there. This is another section of physics simplicity. So before we start, I urge you to click the subscription bell so you can subscribe in order for you to get any forthcoming updates about the physics simplicity. So please, I urge you, I'll give you some few seconds to click the notification bell for you to get more updates. So please quick click the bell and let's go. I believe you are done by now. Okay, let's start physics today. So today, as you can see, I'll be briefing you people the differences between mass and what? And weight. What is the difference between this mass and this weight? There's a big difference between the two of them, but they're almost what? Similar. Now for mass, as we all know, mass can be defined. If I continue, mass can be defined as the total internal content a body has or slash what contains. Now what this means is that is the total amount of the subparticles, the subatoms that are making up an entity. Let's imagine that this is a body. Now what are actually making up this body to make it heavy? What actually making up this body to make it the way it is, rigid and strong and heavy? What actually making this body to be rigid the way they are? So those subparticles are what they call what? The total amount of the internal content that are making up this body. Now those internal content can be gaseous particle, can be liquid particle, or can be what? Solid what? Particles. Now let's say this is the Earth's surface. This is the Earth's surface, and let's quickly do it in chapter. Yes, okay. Now let's say this is the Earth's surface, and these are trees. Now let's bring this rigid particles, this rigid substance on the Earth's surface. Now, for as long as this thing is on the Earth's surface, whether it is being pulled by a force or is being dragged by a force, as long as it's dragged along the Earth's surface, it is referred to as what? Mass. When you want to know the internal content of a body, you pronounce it or know it to be what? Mass. Are you seeing now? For as long as the thing is on the Earth's surface, is being dragged on the Earth's surface, is known to be what? Mass. But what will happen if this mass is being lifted above the Earth's surface? Let's say it's being lifted to this height. How do you call that kind of scenario now? So if it is being lifted above this height, it is no longer called what? Mass, but it is called what? Weight. Because in this case now, this is a mass that is being acted under or against the influence of what? Gravity. Now if you leave this thing above the Earth's surface, it is no longer called mass, it is called weight, because gravitational force is acting on it. Are you seeing it now? So gravitational force is acting on this mass. Hence we can say that weight equals what? The mass of the particle that's been lifted, or the block that's been lifted, times acceleration due to what? Gravity. Due to gravity. And it's usually the measurement for it is usually 10 meters per second. What this 10 meters per second means that every meter, this block, if this block is being released from this certain height, every meter that is being released, it will fall 10 meters per second. I see it now. As your clock ticks, it ticks 1 second. This mass has already dropped 10 meters. Another tick of it has already dropped what? 10 meters. So every 1 seconds, this body is dropping or is falling with an acceleration of what? 10 meters. Are you seeing now? So this mass that is being, the reason why we call it weight is because the mass is being lifted up and gravitational force is acting on it. Gravity is trying to drag it down, but let's say it's being strengthened with a spring balance. Are you seeing it now? So what they use in measuring, so from here we can say that, from here one can simply say that weight is equals to what? Mass times A. This A denotes acceleration. So from here we can simply say that weight is equals to what? Mass times what? G. Let's replace it to what? Gravity. This G stands for what? It stands for gravity. So one can say that W, which is weight, is equals to what? Mg. So this is the general formula for what? Weight. Are you seeing now? So weight is simply the combination of what? Two different things. So weight is the combination of, we now have that weight is called what? Mass is a fundamental unit, is a fundamental quantity, and this other G, bring it here, G is a what? Is a derived quantity. G is a derived quantity. I see it now. So mass is simply, mass is already what? Is a fundamental quantity. Is a fundamental what? Quantity. As we say in our last topic, mass is a fundamental quantity. It cannot be broken down, neither can it be what? Derived. So from here we can say that the SI unit for mass, as we all know, is what? Kilogram. SI unit of weight in this case now. Let's lay it down. Generally, the SI unit of weight is known to be what? Newton. Because it's a force. Weight is a kind of a force that is being acting on a particle. It's a force that is being acting on this particle. What? Let's say this particle, the mass of it, this is what? 50 kg, 50 kilogram. I see it now. So weight is known to be what? Newton. Now we are giving this thing Newton because of who founded or who discovered the law of what? The law of, and that person, the law of gravity. The law of person it is no other person than Isaac Newton. He founded it at age 23 using an apple tree, and that apple tree is still in existence about 300 and something ago. That apple tree is dead. So he discovered this at age 23. What? Gravity. So that's why they are naming this gravity, this energy that has to do with gravity, with the first alphabet of this word of his name. Now let's take this down. Let's try to derive it now. We have it that W is equals to what? Mg. So taking the SI unit of which is, we have it that M is equals to what? Kg times the formula for acceleration. Although I have not treated it, we have to do it what? We say that G is a derived quantity, although I have not treated such. So let me break it down. The formula for acceleration is what? Mx minus what? Or 2 or square, sorry. So we have it that K is equals to what? Kgn ms minus what? 2. So this is another formula for what? This is the fundamental plus derived unit for what? So in case of exam, you didn't see this, but you see the same thing. If you didn't see this and you see this, it's the same thing. Whatever one you see. But normally in exam, to cut story short, and in order to avoid not to avoid problem, most people you will normally see this in exam. So that is the difference. So let's platform. Let's difference between mass, and weight. So the difference is that mass, as we all say, is a what? Is a fundamental quantity. Are we seeing it now? So mass is a fundamental quantity, and weight is a what? Weight is a what? Is a derived quantity. So weight is a derived what? Quantity. So the next one, although I have not treated it, mass is a scalar quantity, of which I'm going to touch all of this. So weight is a what? Weight is a vector. Is a vector quantity. Weight is a vector quantity. Then number 3, the mass of an object is always constant. Whether you take the mass of a block weighing, if you take the mass of this block weighing 100 kg to the moon, the mass remains what? Constant. If you take this to planet Mars, the mass remains constant. this same mass to to Mount Everest, the mass of this block remains what? Constant. But if you take this mass and hang it in a spring in Mount Everest, it's not going to give you the same what? Measurements. If you take the same mass and hang it in a spring in the moon, the weights will not be the same. Let's say the weight of this block, let's say the weight of this block now when it's being hung in the surface of the earth is 10 Newton. Then what will happen if you take this same block to Mount Everest and weigh it? The weight to be what? 10 Newton. You might be having that the weight is going to be, let's say, 7 Newton, because the gravitational force is far from it. So the same thing, if you take the same weight to the moon, the gravitational force is slight. So the weight might be somewhere around 2 Newton. I see it now. So you can say that mass is what? Is constant. Mass is constant throughout everywhere or whichever we want to place it. Then weight does what? What does? Weight varies from one point to another. I'm sorry if I'm writing faster. I just want to cover up. So these are the top differences for what? Mass and weight. So in my next class, I'm going to touch more. So I urge you, before leaving, please do this for me. Click the notification bell for you to get more information. Click the bell for you to get more information. And I thank you so much for my clip. And remain blessed. So wherever you're watching this clip from, you can also like and share to your friends, share to your colleagues, to your high school students, share to your college friends, share to your classmates, so they can get this clip and be fundamentalized. You get? So please, thank you very much.